The skies above are about to witness the most dramatic transformation in air combat since the dawn of jet fighters. At this very moment, in California's Beale Air Force Base, two revolutionary machines are undergoing their final ground tests before taking to the skies this summer. These aren't your typical aircraft. They're autonomous fighter drones with artificial intelligence brains, designated with fighter jet codes for the first time in military history. The YFQ-42A and YFQ-44A represent something the world has never seen before: loyal wingmen that can think, fight, and die for their human pilots without risking a single American life. But here's what makes this absolutely game-changing. A single F-22 Raptor pilot will soon command not just one, but multiple of these AI-powered combat drones simultaneously. While our enemies are still figuring out how to build decent fifth-generation fighters, America is already deploying sixth-generation warfare capabilities. The Air Force isn't just building a few prototypes. They're planning a fleet of 1,000 of these drone-wingmen, fundamentally reshaping how air superiority works forever. Welcome to Jet Insight, where we dive deep into the cutting-edge military technologies that keep America ahead of our adversaries. If you're as excited about this revolutionary leap in American air power as we are, type "proud" in the comments below. The birth of autonomous warriors. The story of these drone wingmen begins with a simple, yet profound realization that struck Air Force leadership. American pilots are irreplaceable, but the missions they fly are becoming impossibly dangerous. Every F-22 Raptor costs $143 million, and more importantly, every pilot represents decades of training and experience that cannot be replaced if lost in combat. The Collaborative Combat Aircraft Program, or CCA as it's known in military circles, emerged from this challenge. On April 24, 2024, the Air Force made a historic decision by selecting two companies to build these revolutionary machines. General Atomics Aeronautical Systems and Anduril Industries received contracts that would change warfare forever. But this wasn't just another defense contract. This was America doubling down on maintaining air superiority against rising threats. General Atomics brought decades of unmanned aircraft experience to the table. Their design, designated YFQ-42A, builds upon their experimental XQ-67A platform that first flew on February 28, 2024. This isn't some paper airplane concept. It's a proven design that prioritizes endurance and stealth over raw speed. The company has logged nearly 9 million flight hours across their unmanned aircraft programs, making them uniquely qualified to build America's first autonomous fighters. Anduril Industries took a different approach with their YFQ-44A, previously known as Fury. This California-based company acquired Blue Force Technologies in September 2023, specifically to enhance their drone into what they call a high-performance multi-mission platform. Their design is approximately half the size of an F-16 Fighting Falcon, featuring trapezoidal wings and a distinctive chin-mounted air intake. The significance of March 2025 cannot be overstated. For the first time in Air Force history, unmanned aircraft received fighter designations. The F in YFQ-42A and YFQ-44A stands for fighter, while the Q indicates unmanned aircraft. Air Force Chief of Staff General David Alvin emphasized this milestone, stating that these designations signal a new chapter in aerial warfare, where autonomous fighters will operate alongside human pilots as equals, not mere tools. When Silicon Valley meets the Pentagon, the technology powering these drone wingmen represents a fusion of military expertise and Silicon Valley innovation that's never been attempted at this scale. The artificial intelligence systems controlling these aircraft aren't simple autopilots. They're sophisticated neural networks capable of making split-second combat decisions that would challenge even experienced pilots. In July 2024, the Air Force awarded contracts to 5 classified vendors for developing the autonomy software that serves as the brain of these machines. Air Force officials described this mission autonomy as the central nervous system that allows these drones to understand their environment, process threats, and execute complex maneuvers without constant human oversight. The classification level surrounding these contracts demonstrates just how revolutionary this technology truly is. The control interface represents another breakthrough in human-machine teaming. Rather than requiring pilots to manage complex control systems, the Air Force has developed tablet-based interfaces that allow F-22 and F-35 pilots to command multiple drones simultaneously. Imagine an iPad that can control a formation of fighter jets. That's the level of technological advancement we're discussing. Lockheed Martin has already demonstrated this capability in flight tests, showing how pilots can seamlessly direct multiple autonomous aircraft from their cockpits. The company conducted successful demonstrations in 2024 using modified aircraft where human operators issued commands to surrogate drones, proving that the concept works in real-world conditions. But the real magic happens in the artificial intelligence algorithms that allow these drones to operate semi-autonomously. Unlike remote-controlled aircraft that require constant human input, these CCAs can interpret mission objectives, navigate complex airspace, and even engage targets based on pre-programmed rules of engagement. The Air Force has been developing these capabilities through programs like the X-62A Vista, a modified F-16 that has been testing AI-powered autonomous flight since 2022. The game-changing capabilities. When these Drone-Wingmen become operational, they'll possess capabilities that fundamentally alter the mathematics of air combat. Each CCA will have a combat radius exceeding 700 nautical miles and stealth characteristics comparable to the F-35 Lightning II. But raw performance numbers only tell part of the story. It's how these capabilities combine that creates true game-changing potential. Consider a typical air-to-air engagement scenario. Currently, when F-22 Raptors encounter enemy fighters, they're limited by their missile capacity and the need to protect the human pilot. Each Raptor carries 8 air-to-air missiles maximum. But imagine that same F-22 controlling 3 Drone-Wingmen, each carrying additional missiles and sensors. Suddenly, one human pilot commands the firepower of 4 aircraft, while only risking 1 human life. The versatility of these platforms extends far beyond traditional fighter roles. The Air Force envisions CCAs performing electronic warfare missions, intelligence gathering, reconnaissance, and even serving as decoys to protect manned aircraft. General Atomics designed their YFQ-42A with an internal weapons bay specifically for carrying not just missiles and kinetic weapons, but also logistics supplies and specialized equipment. This multi-role capability addresses one of the Air Force's biggest challenges, operating from damaged or austere airfields. Mike Atwood from General Atomics revealed that their CCA can function as a mobility aircraft, carrying supplies and equipment to forward bases where traditional cargo aircraft cannot safely operate. This transforms logistics in contested environments where every runway might be under enemy surveillance. The stealth characteristics of these drones represent another quantum leap forward. While specific details remain classified, Air Force graphics indicate that CCA stealth performance matches that of 5th-generation fighters. This means these drones can penetrate enemy air defenses and operate in contested airspace where conventional aircraft would be shot down. America's 6th-generation advantage. The CCA program doesn't exist in isolation. It's part of a larger revolution in American air power, centered around the F-47, America's first 6th-generation fighter. On March 21, 2025, President Donald Trump announced that Boeing had won the contract to build this revolutionary aircraft, marking the beginning of a new era in air superiority. The F-47 designation honors both the legendary P-47 Thunderbolt of World War II and the Air Force's founding year of 1947. But this isn't just symbolic. The F-47 represents the culmination of secret flight testing that began in 2019. For 5 years, experimental aircraft designated as X-planes have been quietly testing the technologies that will power America's next-generation air dominance. Boeing's victory in the F-47 competition wasn't just about building another fighter jet. It was about creating a platform capable of commanding autonomous wingmen while dominating the most contested airspace imaginable. The F-47 will have a combat radius exceeding 1,000 nautical miles, speeds above Mach 2, and stealth capabilities that surpass even the F-22 Raptor. What makes this truly revolutionary is how the F-47 and CCA programs integrate. A single F-47 pilot will command multiple drone wingmen, creating what military strategists call a force multiplier effect. Instead of one-on-one engagements, enemy fighters will face coordinated attacks from multiple platforms controlled by a single highly trained American pilot. The timeline for this transformation is aggressive but achievable. Air Force Chief of Staff General David Alvin stated that the F-47 will fly during the current presidential administration, which ends in January 2029. Meanwhile, CCA prototypes are expected to begin flight testing this summer, with production aircraft entering service before 2030. This represents the fastest development timeline for advanced military aircraft in decades. The Air Force is leveraging digital engineering, rapid prototyping, and commercial technologies to compress development cycles that traditionally took decades into just a few years. Secretary of the Air Force Frank Kendall emphasized that the warfighter needs these capabilities urgently, driving the accelerated timeline, the human-machine partnership. Despite the advanced artificial intelligence controlling these drone wingmen, human pilots remain at the center of this revolution. The Air Force has deliberately designed these systems to enhance human decision-making rather than replace it. This approach reflects hard-learned lessons about the importance of human judgment in complex combat situations. The tablet-based control interfaces represent a breakthrough in making advanced technology accessible to pilots under stress. Rather than requiring extensive retraining on complex systems, pilots can command drone wingmen using intuitive touchscreen controls similar to consumer electronics. This reduces cognitive load and allows pilots to focus on tactical decision-making rather than system management. Voice command integration represents another advancement in human-machine teaming. Air Force Chief of Staff General C.Q. Brown explained that pilots will be able to issue verbal commands to their drone wingmen, similar to how we interact with smartphones and smart home devices in daily life. The technology exists. The challenge is adapting it for high-stress combat environments where clear communication can mean the difference between mission success and failure. The autonomy levels built into these systems are carefully calibrated to maintain human oversight while reducing pilot workload. The drones can navigate autonomously, avoid obstacles, and maintain formation without constant input. However, critical decisions about weapon engagement and target selection remain under human control, ensuring that ethical considerations and rules of engagement are properly maintained. Training programs are already being developed to prepare pilots for this new era of human-machine teaming. The Air Force has established the Experimental Operations Unit at Nellis Air Force Base in Nevada, which was elevated to squadron status in June 2025. This unit will develop tactics, techniques, and procedures for operating with autonomous wingmen while training the first generation of pilots who will command these revolutionary systems. Global implications and strategic advantage. America's lead in autonomous fighter technology isn't just a technological achievement. It's a strategic advantage that could determine the outcome of future conflicts. While potential adversaries struggle with fifth-generation fighter development, America is already deploying sixth-generation capabilities that fundamentally change the rules of engagement. China's attempts to develop loyal wingman drones like the Feihong FH-97A highlight the strategic importance of this technology. However, Chinese systems appear to lag significantly behind American capabilities in both artificial intelligence sophistication and integration with manned fighters. The complexity of developing truly autonomous combat systems requires expertise in multiple advanced technologies, where America maintains clear advantages. Russia's Sukhoi S-70, Okhotnik, and Kronstadt Grom programs represent their attempts to field similar capabilities. But Western intelligence assessments suggest these systems lack the advanced autonomy and artificial intelligence integration found in American designs. The production challenges facing Russian defense industries following international sanctions further limit their ability to field these systems at scale. Allied nations are also pursuing loyal wingman programs, but most are designed to complement rather than compete with American systems. Australia's Boeing MQ-28. A Ghostbat has completed over 100 hours of flight testing and represents a successful model for international cooperation. The Royal Australian Air Force has invested over 600 million Australian dollars in this program, which will likely integrate with American systems in future conflicts. European efforts like the Eurofighter Consortium's Wingman drone and France's Rafale companion systems demonstrate Allied recognition of this technology's importance. However, these programs generally focus on regional requirements rather than the global reach and advanced capabilities that characterize American systems. The strategic implications extend beyond pure military capability, Nations that master human-machine teaming in military applications will likely lead in civilian applications of autonomous systems, from commercial aviation to autonomous vehicles. The technologies being developed for CCA programs will eventually transform civilian industries, providing economic benefits that extend far beyond defense applications. Testing and validation. The current ground testing phase at Beale Air Force Base represents the culmination of years of development and the beginning of operational validation. These tests evaluate everything from propulsion systems and avionics to the complex software that enables autonomous operation. Each system must prove its reliability and effectiveness before American pilots trust their lives to these machines. Ground testing protocols for autonomous fighters are necessarily more complex than traditional aircraft because of the artificial intelligence components. Engineers must validate not just mechanical systems, but also the decision-making algorithms that will control these aircraft in combat. This includes testing scenarios where human pilots lose communication with their Drone-Wingman and the artificial intelligence must operate independently. The Air Force has designated Beale Air Force Base as the CCA Aircraft Readiness Unit, where these revolutionary aircraft will be maintained in fly-ready status for rapid deployment worldwide. Unlike traditional fighter squadrons that require daily training flights to maintain pilot proficiency, CCA units will operate with minimal flight time because the artificial intelligence doesn't require practice to maintain its skills. Flight testing will begin this summer with carefully controlled scenarios designed to validate the safety and effectiveness of human-machine teaming. Initial tests will focus on basic formation flying and communication protocols before progressing to more complex combat scenarios. The Air Force has learned from decades of unmanned aircraft operations to develop comprehensive testing protocols that ensure these systems are ready for operational deployment. The competitive evaluation between General Atomics and Anduril will conclude in fiscal year 2026, when the Air Force selects which design will enter production. Both companies must demonstrate not just technical capability, but also their ability to manufacture these complex systems at scale. The winner will potentially receive contracts worth hundreds of billions of dollars over the program's lifetime. Revolutionary operational concepts. The introduction of Drone-Wingman will revolutionize how the Air Force conducts operations in contested environments. Traditional concepts of air superiority assumed relatively equal exchanges between opposing fighters. Drone-Wingmen fundamentally alter this calculation by allowing one human pilot to command multiple combat platforms simultaneously. Consider deep strike missions into heavily defended airspace. Currently, such missions require large packages of fighters, electronic warfare aircraft, and support platforms, each with human crews at risk. With Drone-Wingmen, a smaller number of manned aircraft can achieve the same objectives while putting fewer American lives at risk. The drones can fly the most dangerous portions of the mission, while human pilots coordinate from safer positions. Air Force Major General Joseph Kunkel has indicated that future CCA increments may be even more cost-effective and numerous than the current prototypes. The service is exploring concepts for air-launched drones that can be deployed from larger aircraft, further extending their reach and reducing dependence on traditional runways that might be targeted by enemy forces. The agile combat employment strategy that the Air Force has adopted relies heavily on operating from dispersed, austere airfields to complicate enemy targeting. Drone-Wingmen support this concept by requiring less infrastructure and support equipment than traditional fighters. They can operate from shorter runways and require fewer maintenance personnel, making them ideal for forward deployment. Electronic warfare represents another area where Drone-Wingmen provide revolutionary capabilities. These platforms can carry sophisticated jamming equipment and decoys while operating in close proximity to enemy air defenses. If a drone is lost to enemy action, the mission can continue without the tragic loss of American aircrew that would result from shooting down a manned aircraft. The industrial base revolution. The development of Drone-Wingmen is driving innovations throughout the American defense industrial base that extend far beyond the aircraft themselves. The artificial intelligence systems, advanced materials, and manufacturing techniques being developed for these programs are creating technological advantages that benefit multiple industries. Boeing's victory in the F-47 competition represents a major milestone for American aerospace manufacturing. The company has made what it calls the most significant investment in the history of our defense business to develop sixth-generation fighter capabilities. This investment revitalizes American fighter production lines and ensures continued American leadership in advanced aerospace technologies. The software-defined nature of these systems represents a fundamental shift in how military aircraft are developed and maintained. Rather than hardware-centric designs that remain largely unchanged throughout their service lives, Drone-Wingmen can be continuously updated with new capabilities through software modifications. This approach, borrowed from commercial technology companies, allows rapid adaptation to emerging threats. Advanced manufacturing techniques being developed for CCA production include additive manufacturing, digital twin technology, and artificial intelligence-assisted quality control. These innovations reduce production costs while improving performance and reliability. The Air Force's emphasis on open architecture designs ensures that multiple companies can contribute components and subsystems, fostering competition and innovation. The supply chain implications are equally significant. Traditional fighter aircraft require thousands of specialized components from hundreds of suppliers. Drone-Wingmen leverage commercial technologies where possible, reducing costs and improving reliability while ensuring that supply chains remain resilient in the face of potential disruptions. Are you a military veteran or military enthusiast? We've built an amazing community of veterans and active service members who share insights and experiences about these incredible technologies. Join our community to connect with fellow patriots who understand the importance of American military superiority, looking toward the future. The current CCA program represents just the beginning of a transformation that will continue evolving over the coming decades. The Air Force is already planning Increment 2 of the program, which will feature even more advanced capabilities and potentially lower costs through improved manufacturing techniques and economies of scale. Future Drone-Wingmen may incorporate technologies that seem like science fiction today. Advanced artificial intelligence could enable these systems to learn and adapt from combat experience, becoming more effective over time. Swarm intelligence concepts could allow multiple drones to coordinate autonomously, creating emergent behaviors that no human operator directly programmed. The integration of space-based sensors and communications will further enhance Drone-Wingman capabilities. Real-time data from satellites can provide these systems with unprecedented situational awareness, allowing them to respond to threats that haven't even been detected by traditional sensors. This creates a truly networked force, where information superiority translates directly into combat advantage. Hypersonic weapons integration represents another frontier for Drone-Wingman development. These platforms could serve as launch platforms for hypersonic missiles, extending their range and providing multiple attack vectors that would be impossible for enemies to defend against. The combination of stealth, speed, and hypersonic weapons creates a capability that no current defense system can effectively counter. Energy weapons and directed energy systems may eventually be integrated into Drone-Wingman platforms. The absence of human crews means these aircraft can carry more electrical power generation and storage systems needed for laser weapons and electronic warfare systems. This could enable non-kinetic mission capabilities that disable rather than destroy enemy systems. The human element remains supreme. Despite all the advanced technology and artificial intelligence, the success of Drone-Wingman ultimately depends on the skill, judgment, and courage of American pilots. These systems are designed to amplify human capabilities rather than replace human decision-making. The most sophisticated artificial intelligence still cannot match human creativity, adaptability, and moral reasoning in complex combat situations. The pilots who will command these revolutionary systems represent the finest military aviators in the world. Their training combines traditional piloting skills with new competencies in human-machine teaming and autonomous systems management. These pilots must understand not just how to fly their own aircraft, but how to effectively command and coordinate multiple autonomous platforms simultaneously. The ethical implications of autonomous weapon systems remain an important consideration in CCA development. The Air Force has maintained that human operators retain ultimate authority over weapon engagement decisions, ensuring that these systems remain tools under human control rather than independent actors. This approach maintains compliance with international laws of armed conflict while maximizing operational effectiveness. Combat leadership in this new era requires different skills than traditional fighter pilot training provided. Pilots must think tactically about multiple platforms simultaneously, while maintaining awareness of the broader battle space. They become force commanders rather than individual warriors, multiplying their effectiveness through technology while maintaining the human judgment that remains irreplaceable in warfare. The promise of American innovation. The Drone-Wingman revolution showcases everything that makes American military innovation exceptional. The combination of visionary leadership, technological excellence, industrial capacity, and the warrior spirit that defines our armed forces. This isn't just about building better weapons. It's about maintaining the technological edge that keeps America safe and preserves freedom around the world. The speed of this development demonstrates what American industry can achieve when properly motivated and funded. From concept to flying prototypes in just a few years represents a pace of innovation that our adversaries simply cannot match. This rapid development cycle will become even more important as technological change accelerates and new threats emerge. The integration of commercial technologies and startup innovation with traditional defense contractors shows how America leverages its entire technological ecosystem for national security. Companies like Enduril bring fresh perspectives and cutting-edge software capabilities, while established firms like General Atomics provide proven experience in complex systems integration. International cooperation on these programs strengthens relationships with allies while ensuring interoperability in future conflicts. Australian, European, and other allied systems will work alongside American platforms, creating a networked force that multiplies the effectiveness of democratic nations while complicating planning for potential adversaries. The economic benefits of these programs extend far beyond the defense industry. The technologies being developed for military applications will eventually transform civilian aviation, autonomous vehicles, artificial intelligence, and numerous other industries. America's investment in military innovation pays dividends across the entire economy while maintaining our technological leadership globally. Conclusion. The Drone-Wingmen now preparing for their first flights represent more than just advanced military technology. They symbolize America's commitment to maintaining peace through strength and protecting those who serve in uniform. These remarkable machines will allow our pilots to accomplish missions that would be impossible or prohibitively dangerous with traditional aircraft alone. As these revolutionary systems enter service over the coming years, they will fundamentally change how America projects power and maintains security around the world. The combination of human expertise and artificial intelligence creates capabilities that our adversaries cannot match and our allies can depend upon. The young Americans who will pilot these systems carry forward a tradition of excellence that stretches back to the earliest days of military aviation. They represent the best of American innovation, courage, and dedication to defending freedom. With Drone-Wingman at their side, they will write the next chapter in the story of American air superiority. The future of air combat isn't about replacing pilots. It's about giving them tools worthy of their skill and dedication. These Drone-Wingmen will serve alongside the finest military aviators in the world, multiplying their effectiveness while keeping them safe. That's a future worth fighting for, and it's a future that's arriving faster than most people realize. The skies above America will soon be filled with the sound of freedom, powered by artificial intelligence, guided by human wisdom, and dedicated to protecting the values we hold dear. The age of Drone-Wingman has arrived, and America is leading the way. If you enjoyed learning about these incredible developments in American military aviation, make sure to hit that like button and subscribe for more in-depth coverage of the technologies keeping America safe. Let us know in the comments what aspect of these Drone-Wingmen impressed you the most.